The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program, CXC Mathematics in Focus. Lesson 27, Non-Routine Problems. In recent years, CXC has introduced into its examination non-routine mathematical problems which have more than one correct method in solving them. In this lesson, we will examine some non-routine problems that are posed to children in order to develop their higher order thinking skills. Very often, patterns have to be discovered and a general rule created to explain the pattern. Here is an example of a non-routine problem. In the first column, we have polygon. In the second column, number of sides on the polygon. And in the third column, number of diagonals on the polygon. The first shape, which is a triangle, has 3 sides and no diagonal. There is no diagonal in the triangle. The second shape, which is a quadrilateral has 4 sides, and if you insert the diagonals, you would discover that you have in any quadrilateral 2 diagonals. The pentagon, which is the third shape, has 5 sides, and inserting the diagonals, we will find that in a pentagon we have 5 diagonals. In this slide, the first shape there is the hexagon. The hexagon has 6 sides, and when the diagonals are drawn in as shown, we will have 9 diagonals. And the second shape there, 8 sides, it's called an octagon. When the diagonals are drawn, we discover that there are 20 diagonals to the octagon. If we have a polygon of n sides, and we have not drawn the n-sided polygon for you, you can try to do that. The number of diagonals is found by taking the number of sides, which is n, and subtracting 3 and multiply n by 3 and divide by 2. So, the formula for finding the number of diagonals in a polygon is n into n minus 3 divided by 2. Try it with 6 as seen above there. When n is 6, it will be 6 times 6 minus 3, which is 3. So, 6, which will be 9. Try it for the octagon, 8 sides. So, it will be 8 times 5, that is 8 minus 3 would be 5. 8 times 5, 40. 40 divided by 2 will give you 20. So, the formula seems to be holding good so far. You can test it out for other polygons on your own. Here is one taken from CXC January 2007. A large equilateral triangle is subdivided into a set of smaller equilateral triangles by the following procedure. The midpoints of the sides of each equilateral triangle are joined to form a new set of smaller triangles. The procedure is repeated many times. The table in the next slide shows the results when the above procedure has been repeated twice, that is, when n is equal to 2. Let's look at the table. When n is 0, we have a triangle with no subdivision, so the number of triangles formed is just 1. When n is equal to 1, we have the first set of subdivision. That is, we select the midpoints of the side, join them, and then we count the number of small triangles we have. Counting, we would recognize that there are 4 triangles in the second shape, small triangles. In the third shape, we repeat the procedure a second time. That is, for each triangle in the second shape, we find the midpoints and join them, and we will end up with what we have in the third shape. And when we count the number of small triangles, we will discover that there are 16 small triangles. Now, you're asked to fill in the gaps here. When n is equal to 3, what that shape would look like. So you are required to draw that in the middle there, and then determine the number of triangles formed, and that is labeled little Roman 1, and that is what you have to calculate in a moment. When n is 6, that is the step repeated 6 times, we have to find out the number of triangles formed, which is labeled Roman 2. Then the third part, Roman 3, we are told that the number of triangles formed is 65,536. We are required to determine what is the value of n to give us that result. And then you're told in the last row there that if n is equal to m, what formula we will find to determine number of small triangles, and that is Roman 4. So we have to find those missing values 1, 2, 3, and 4. Here are the results. When n is equal to 3, and from your drawing you would discover that the number of triangles formed is 64. That's on your right in the second row. When n is 6, we'll discover from the practical exercise that the number of triangles formed is 4,096. And in the third part, if we know that the number of small triangles is 65,536, then n must be 8. When n is equal to m, what is the formula for finding the number of triangles? It is 4 to the mth power, that is the index being m for the number 4. Now, in that formula 4 to the m power, if we replace m by 8 and use your calculator to determine what answer you will get, and you use the power function on the calculator, you will end up with a result 65,536. When m is equal to 6, again on your calculator you will have 4,096, and so you can try it for m equal to 3. Here's another problem taken from CXC June 2005. Study the number pattern in the table below and complete lines 1, 2, and 3 as marked by those Roman numerals. In the first row, we have 2 cubed, and in the second column of the first row, it is 0 times 3 square plus 3 times 2 plus 2 When that is worked out, we have 8. So 2 cubed will give us the same answer as in the middle and the answer 8 on the right. 3 cubed is expressed as 1 times 4 square plus 3 times 3 plus 2. And that is worked out, it is 27. 4 cubed is expressed as 2 times 5 square plus 3 times 4 plus 2, which is 64. And so for 5 cubed, we are asked to find what 6 cubed would be, what 10 cubed would be, what n cubed would be, with n missing in the second row, the second column. Here is the solution. The first row is given, the second row given, the third row given, the fourth row given. Let's see the first part, 6 cubed. If we look at the pattern for the first 4, we'll find that 6 cubed can be expressed as 4 times 7 square plus 3 times 6 plus 2. When that is worked out, we have 216. 10 cubed can be expressed as 8 times 11 square plus 3 times 10 plus 2. When that is worked out, it is the same as 1000. When we have to find n cubed, we will have to determine what the missing element in the brackets were. And that is expressed as n minus 2 times n plus 1 all square plus 3 times n plus 2. When that expression is simplified, we'll end up with n cubed. Now, that is the formula for determining the solution to the exercises given earlier in the 2 cubed, 3 cubed, 4 cubed, 5 cubed. So you apply that formula and you'll get the answers to the right. So the general formula for n cubed is n minus 2 times n plus 1 all square plus 3 times n plus 2. Here is your problem for today. In the first column, we have shape. In the second column, we have the area of the shape. In the third column, we have the perimeter of the shape. The first shape, there is a square, a small one. The area is 1, the perimeter 4. The second shape is made up of 2 small squares. The area is 2, the perimeter 6. The third shape is 3 little squares put together. The area is 3 and the perimeter is 8. You're asked to draw the next 2 shapes to continue the sequence. Part B. For each shape drawn in Part A, complete the table by stating the area of the shape and the perimeter of the shape. Part C. A shape in the sequence has an area of 12 square units. What is the perimeter of the shape? Part D. A shape in the sequence has a perimeter of 40 units. What is the area of this shape? Part E. Draw 2 shapes, each made up of 4 unit squares, so that one has a perimeter of 8 units and the other has a perimeter of 16 units. This is a problem given to you in the last lesson. Part A. P is the point 24 and Q is a point 610. Calculate the gradient of PQ. Calculate the midpoint of PQ. This part of the question is taken from CXC January 2007. Part B of the question. In triangle JKL, the coordinates of the vertices are J01, K5 minus 4, and L72. Part 1. Draw triangle JKL. Part 2. Determine the coordinates of M, the midpoint of KL. And 3. Show by calculation that JK is equal to JL. And this part of the question is taken from CXC June 2002. Here is the solution to part A. The gradient of PQ is equal to 10 minus 4 divided by 5 minus 2, which is equal to 3 halves. That is the difference in the y value divided by the difference in the x values. The midpoint of PQ is equal to 4, 7. That is, you add the x values and divide by 2. Then you add the y values and divide by 2. So 6 plus 2 divided by 2 is 4. 10 plus 4 divided by 2, which is 7. Here's the solution to part B. On your graph, the points plotted and the triangle drawn would look like this. You see J, K, L. We are asked to show by calculation that JK is equal to JL. Using Pythagoras' theorem and apply it, you will find that JK is equal to the square root of 5 squared plus 5 squared, which is equal to the square root of 50. Finding JL will give us square root of 7 squared plus 1 squared, which will be the square root of 50. We find that JK is equal to square root of 50. JL is equal to square root of 50. So we can conclude that JK is equal to JL. In lesson 22, this problem was given. It was taken from CXC January 2006. The curved surface area of a cylinder is 2 pi rh, where r is the radius and h is the height, and the surface area of a sphere is 4 pi r squared. The diagram above, not drawn to scale, shows a solid glass paperweight which consists of a hemisphere mounted on a cylinder. The radius of the hemisphere is 3 cm, the radius of the cylinder is 3 cm, and the height is 8 cm. 1. Calculate the curved surface area of the cylinder. Part 2. Calculate the surface area of the hemisphere. And part 3. Calculate the total surface area of the solid paperweight. Here is the solution. Part of this solution was omitted in the previous lesson. The curved surface area of the cylinder is equal to 2 pi r h, and when we substitute the values for pi, r, and h, we will have a curved surface area of 150.72 cm squared. The area of the hemisphere is half the area, the surface area of a sphere. The surface area of a sphere is 4 pi r squared. Half of that will give us 2 pi r squared. Substituting the value for r will give us a surface area for the hemisphere as 56.52 cm square. Then we have to find the area of the base, which is a circle, and the area is pi r squared. Substituting for r, we have an area of the base as 28.26 cm squared. So the total surface area will be the sum of the three numbers, 150.72 plus 56.52 plus 28.26 will give us a total surface area of 235.5 cm squared. This brings us to the end of today's program, CXC Mathematics in Focus.
We will continue looking at grammar rules in this lesson. The relative pronoun as subject. In some sentences, the relative pronoun is the subject of the sentence. In this case, the noun that comes before the relative pronoun will determine the number of the verb that will be used. Let us look at these examples. I like people who are lively. I like a man who has energy. Sergeant James is the only of the officers who sings in the choir. In sentence 1, the noun that comes before the relative pronoun is plural, so the plural verb is used. In sentences 2 and 3, the noun that comes before the relative pronoun in each case is singular, so the singular verb is used. Sergeant Smith is one of those officers who annoy me. It is obvious that the plural verb has to be used in this sentence since those officers is plural. 2. The verb before the subject and the clauses and phrases as subjects. Sometimes you get confused when the verb comes before the subject or when clauses and phrases are the subject in the sentence. However, the same rule applies. The verb is not at all affected by this. Let us look at the following examples. Here comes the elephant. The subject is the elephant, which is singular, so the singular verb is used. The next day, there were several notices and a new cafeteria schedule on the bulletin board. The subject is there were several notices and a new cafeteria schedule on the bulletin board, which is plural, so the plural verb is used. Aren't there more than 2 letters in the box? The subject is 2 letters, which is plural, so the plural verb is used. Choice of the correct form of the pronoun. The pronoun as subject of the verb. He marches in the parade. His parents disinherited wrath because he was not a good son. They and I are to visit London soon. In the sentences above, the pronouns underlined are subjects, so the subjective case is used. The pronoun as predicate complement. It is they. It wasn't she who was wrong. It was we. In the sentences above, each of the pronouns is a verb complement, so the subjective case is used. The pronoun in apposition with the subject. 2 speakers, Pat and she, had the flu. People who know pain, they and they only know the fullness of life. In the above sentences, the underlined pronouns are in apposition with the subject, so the subjective case is used. The pronoun as object of the verb. We saw Marjorie and him last week. I admire him, but the others in the crowd whom I know too well I despise. Did they notify anyone? Yes, Glenn and me. In the above sentences, the pronouns are all objects of the verb, so the objective case is used. The pronoun as object of a preposition. Everyone was red except him and us. Everyone fled but him. Fools like them need specific instructions. In the above sentences, the pronouns are all objects of the preposition, so the objective case is used. The pronoun in apposition of the object. They nominated Henry for chairman, him of all people. Dad gave the girls, Joan and her, permission to drive the car. He cared for both of them, him and her. In each of the sentences above, the underlined pronoun is in apposition of the object, so the objective case is used. The pronoun as subject or object of the infinitive. His instructors considered him to be promising. The investigator suspected the embezzler to be him. The pronoun as subject or object of the infinitive. When the pronoun is a subject or object of the infinitive, to, as in the sentences above, the objective case is used. Now, boys and girls, we look at the pronoun in comparison. A pronoun following than or as takes the subjective or objective case, according to whether the pronoun is subject or object of the implied verb. His brother is a better tennis player than he, and is implied. In this sentence, the pronoun is a subject of the implied verb is, so the subjective case is used. Since George seldom gets upset, the traffic bothered me more than him. In this sentence, the pronoun is the object of the verb, so the objective case is used. Two other examples are, they misjudge Paul as much as I, subjective. They misjudge Paul as much as me, objective. Sentence structure. Now we'll deal with omission of articles, possessives, and connectives. Can cause sentences to be confusing. Here are some examples. Confusing. The heiress bought a gold and silver urn. And the clear version, the heiress bought a gold and a silver urn. Another confusing sentence, he left the money to his wife and aunt. The clear version, he left the money to his wife and his aunt. The school bell rang the same time as always. The school bell rang at the same time as always. Omission of forms of main or ancillary verbs. Poor. Edward is intelligent, but all the others stupid. Improved version will be, Edward is intelligent, but all the others are stupid. Yes. Another example of a poor sentence. We work as diligently as they have or are working. Correct version. We work as diligently as they have worked or are working. The violinist was in superb form and applauded by the entire audience. The improved version is the violinist was in superb form and was applauded by the entire audience. Omission of words necessary to complete the meaning of a sentence. One of the problems in administering Oxfam is that some countries need more than others. Now the correction. One of the problems in administering Oxfam is that some countries need more funds than others do. The right preposition to use after certain words depends on the meaning intended. Examples: an abhorrence of violence, acquiesced in the plan, quite adequate to our needs, the supplement appended to it, an authority on birds, views that coincide with mine, compiled with her request, concern for her health, conducive to clear thinking, ideas that conformed to mine, demure at his plan, disconcerted by his heckling, dispossessed of their land, eligible for the office, encumbered with debts, engrossed in their gain, enveloped in clouds, his familiarity with Latin, her great fear of spiders, hankered after the sea, kept harping on the coast, a hindrance to us, identical with his, intolerant of any delay, irrelevant to the matter, irrespective of their ages, mindful of his warning, a partiality for sweets, proficient in typing, to requite evil with good. One similar to this, tolerant of his opinion. Boys and girls, we have given you a lot to remember in the rules of grammar. We hope that you will read further texts for more examples. On behalf of B.B. Ali, Parmeshwar Lal and Manchester, I'm in the promise saying good night.
The National Communications Network, in collaboration with the National Center for Resource Development and the Ministry of Education, present CXC in Focus, a focus on the key subject areas of mathematics and English for students preparing to write the exams.
Welcome to another program, CXC Mathematics in Focus. Lesson 28, Statistics, Measures of Central Tendency and Dispersion. In this lesson, we are going to calculate measures of central tendency and dispersion. Measures of central tendency are commonly called averages. There are several averages, but in this lesson, we are going to look at the arithmetic mean, or just the mean, the mode, and the median. Measures of dispersion are numbers that indicate the nature of the spread of the scores. Common measures of dispersion are the range, the interquartile range, the semi-interquartile range, the deviation, the variance, and lastly, the standard deviation. Measures of central tendency or averages. Mean. The mean is defined as a sum of the scores divided by the number of scores. The mode. Mode is defined as a score that occurs most frequently. There are times when a distribution of scores can have more than one mode. The median. To determine the median of a set of scores, we first arrange the scores either in ascending order or descending order, and then determine the score that is in the middle of the distribution. If there is an odd number of scores, then there is a unique number in the middle. If, however, there is an even number of scores in the distribution, then two numbers are in the middle, and so to find the median, we take the mean of the two middle numbers. Here are some examples to show how measures of central tendency are determined. First, the mean. Find the mean of the following numbers: 12, 36, 27, 42, 9, 24, 40, 8, 17, 48, 24, 15. 12 numbers. The sum of those numbers is 312. The mean is found by dividing 312 by 12, which will give us 26. So the mean of the set of scores is 26. The mode. The mode is determined by pure observation. The most frequent score in the distribution is 24. So the mode is 24. The median. To find the median, we rearrange the following scores in ascending order. Those are the numbers given: 12, 36, 27, 42, 19, and so on. The rearranged scores are given here, the lowest being 8, followed by 12, 13, 15, 17, 19, and so on unto 48. The score that stands in the middle is 23. So the median is 23. Note, in this distribution, we have an odd number of scores, which is 13. 13 numbers there. So the seventh score in the order is a median, which is 23. 23 is the seventh score. Try to do an example with a distribution containing an even number of scores. Measures of dispersion. First measure, the range. Range is the difference between the highest and lowest scores. The interquartile range. The interquartile range is the difference between the third quartile and the first quartile. The three quartile marks divide the distribution into 4 equal parts in rank order. The semi-interquartile range. The semi-interquartile range is half the quartile range. Deviation. Deviation is the difference of each score from the mean score. The variance. Variance is calculated as the mean of the deviation squared, and the standard deviation is calculated as the square root of the variance. So standard deviation is the square root of the variance. Here are some examples to show how measures of dispersion are calculated. First, the range. Here we have a set of scores starting with 12, then 36, right on to the last one, which is 15. We look through the scores to find which one is the highest. The highest score is 48. And we also notice that the lowest score is 8. The range is defined as the highest score minus the lowest score. So the range is 48, which is the highest score, minus 8, which is the lowest score, which will give us a range of 40. Quartile marks. The quartile marks are numbers that mark the division points where the distribution is divided into quarters as shown below. We have the scores arranged in order, lowest to highest. We find the score that is in the middle. Earlier we saw 23 is in the middle of this set of score, and that is labeled Q2, meaning the second quartile. Halfway between the scores to the left of the second quartile is Q1, and the middle would be a number between 13 and 15. To the right, the third quartile is the middle of the scores to the right of Q2, which would be a number between 36 and 40. The first quartile is the mean of 13 and 15, which is equal to 14. That is, if we add 13 and 15 and divide by 2, we will get 14. Q2, as mentioned, is the median or the middle score. Q3 is between 36 and 40. So to find what that number is, we find a mean of 36 and 40, which would be 36 plus 40 divided by 2, which will give us 38. Q1 is the first quartile, and Q2 is the second quartile or the median. Q3 is the third quartile, and those are the quartile marks as given by those numbers 14, 23, and 38. The interquartile range. We found that the first quartile is 14 and the third quartile is 38. The interquartile range for the scores is calculated as Q3 minus Q1, which is equal to 38 minus 14, which will give us 24. So the interquartile range for the scores above is 24. The semi-interquartile range for the same set of scores, 8, 12, 13, right on to 48. The semi-interquartile range for the scores above is a half of Q3 minus Q1, which is equal to a half of 24, which is 12. So the semi-interquartile range for the scores above is 12. Deviation from the mean. The mean score for the scores, we label the scores X in the table, is 26. The deviation of each score from the mean is in the second row, which we call deviation, DV. The deviation is calculated as X minus 26. Each score in the first row is, we have 26 subtracted from it. So the first one, 12 minus 26, will give us minus 14. 36 minus 26 will give us 10. 27 minus 26 will give us 1, and so on.